All right. Well, we're going to talk about next is we're going to be talking about confidence level. You should have probably just figured out, okay, what is confidence interval? All right. And you notice that you have a confidence interval is when you have your point of estimation, which is use your P or whatever your hat is. So you have your point estimate. All right. And then you're going to take and you're going to add and subtract some sort of margin of error, And so our margin of error, all right, that we're going to add and subtract to each one of these point estimates, okay, give us our confidence interval, okay, gives us the confidence interval. And a confidence interval is what is the percentage that we are confident that the true proportion or true mean will be between some sort of values, okay? Now, a confidence level is an offshoot of that and essentially is saying how confident are we of the confidence interval, okay? And that's what a confidence level is. And so we're going to talk about right now is how do we describe a confidence size, what is a confidence interval, talk about the sample size, the confidence, and the confidence interval, how that impacts confidence level, affects the margin of error, and so on and so forth. And explain how practical uses like non-response, under coverage, and why bias doesn't really affect the confidence interval. That just makes things bad. Okay, so let's talk about this. So here are some notes you probably want to jot down. So the first learning target is confidence level. So what is a confidence level? Well, a confidence level is if we make many of a certain confidence percentage of confidence interval. So for example, each time we make a confidence interval, okay, we need a point estimate. Now that could be here or we could have a mean. So we find our point estimate. Okay, now these point estimates are different each time we make a confidence interval because we take a random sample of something, we come up with a point estimate, all right, from our population, and from that point estimate, we go and create a margin of error, all right, and we create all these different confidence intervals. So what we could really have is we have a point estimate here, we could say this point estimate 1, and then we have our confidence interval, so we have this one right here, and this is going to be let's just say 95% confidence level. And now we could have another point estimate, but our point estimate is over here. And then we have this kind of a similar margin of error, but we have it right there. And then you might say, okay, I have another confidence point estimate right here. And we start seeing, okay, we have all this right there. And you start realizing that each time you make, all right, a new point estimate, okay, is that your confidence intervals will be different. Now, what it's saying here is that every time you make a point estimate, is that you make several different ones, and you can make an infinite amount, okay, or at least however many combinations of point estimate you can possibly make out of the population. And so what happens is that when we do many of these, we know that if we make 90, like a 95% confidence interval, that 95% of the time, the confidence interval we expect about, all right, if we make many 95% confidence intervals, we expect about 95% of the time to capture the true proportion or mean of the population, okay? Because parameter means population, okay? All right, is associated with population. And that's what we have. So if we make many 95% confidence intervals, we expect that 95% of them. If we made a bunch of 99% confidence intervals, we expect that 99% of them will actually capture the true population, or the true proportion or mean of the population. And so that is what we talk about. We make many of them, and we expect that the same percentage will actually be captured in that. All right, so with knowing what a confidence level is, so it is different than confidence intervals, essentially is making many confidence intervals and knowing that that same percentage will actually, the number of those will capture the true proportion or mean of the parameter or the population. So now the question is, what effects does different criteria have? What effects does the margin of error have? Okay, what affects margin of error? Okay, so when we have margin of error, remember that we have confidence intervals come from, all right, a point estimate, all right, plus and minus our margin of error. Now, our margin of error, if we increase the confidence level, so if we increase the confidence level, all right, the margin of error will also increase. That means it will get wider. And that makes sense because we need to, if we increase this, we said, and if you looked at some previous videos, is that if we had a 95% confidence, it might be this long. However, or the range is this long. However, if we have a 99, well, in order to guarantee that 99% confidence, we are going to have a larger confidence, all right, interval. All right, and if that is going to, and we know that the confidence interval directly is associated with the confidence level. So if we increase the confidence level, we will have to then, all right, transitory increase the margin of error. In addition, if we increase sample size, now what happens when we increase in sample size? Well, margin of error is a is essentially something we talk about variation. All right, variation. Okay, the variance. Okay, the spread of our confidence interval. So margin of error is a unit of spread, okay, of variation. A variation, there we go, variation, okay, a variation, or a variation. Okay, so when we talk about sample size, what do we know in all the other things? If you've been taking stats for a while in AP stats, you know that whenever you increase sample size, it decreases, all right, spread, okay? It decreases error, okay, or the standard deviation, correct? Standard deviation. Well, margin of error is an offshoot of standard deviation, is associated with standard deviation, and so the margin of error will also decrease. All right, the margin of error will also decrease. So increased sample size decreases margin of error. Increased confidence level increases margin of error. All right, because we need a wider, all right, interval in order to have that much confidence, all right, in what we're doing. And then finally, the last thing is that when we talk about margin of error never accounts for bias. Okay, never accounts for bias. So bad data is bad data. All right, and so margin of error just takes the data you got, whatever point estimate you have, and then we just assume that that's going to be non-biased, and we make a confidence interval. So margin of error, it never accounts for bias. Okay, never counts. So if you just remember this, bad data, all right, is bad data. Okay, we can do all the things we want, but bad data will lead to bad results and leads to bad, all right, inaccurate, I should say that, inaccurate, all right, results. So, so margin of error is not affected by bias. It's just simply, it just doesn't give us the right answer. Okay, so in doing that. All right, so I hope this helps you out and getting some context of what the difference between confidence intervals are and confidence levels. Okay, so confidence levels are doing many confidence intervals of certain some sort of percentage. Okay, and that we know that we will get that percentage of the confidence intervals. All right, with that certain confidence level. We know that sample size directly affects margin of error, and actually, if the sample size is increased, margin of error will decrease. Okay, they have inverse variation there. Okay. And then I explain how practical use of non-response. Well, anytime you use non-response by under coverage and you get a poor point estimate, that's going to lead to bad results, all right, inaccurate results. However, it does not affect the margin of error. All right, well, good luck and God bless, and we're going to show you in the next video, go through a problem using confidence level.